Hello friends. So inverse hyperbolic function is very interesting topic of engineering mathematics, and today we are going to solve the question based on inverse hyperbolic function. So here we'll see how to prove the given question using the concepts of inverse hyperbolic function. So here we have to prove that sine inverse of cosec theta is equal to pi by 2 plus I log of cot theta upon 2. Now the thing is, you must be thinking, how is it inverse hyperbolic function? So yes, you are correct. By looking at the question, we can't say that it's inverse hyperbolic function because here we do not have hyperbolic function itself. So here you can see that here it is inverse trigonometric function. But since it is missing h, we will not call it as inverse hyperbolic function. So you must be thinking, why are we solving this question by using inverse hyperbolic function formulae? So guys, right now the formulae of inverse hyperbolic functions are of no use. But when we'll solve this problem, then in middle of the problem, we may require the formula of inverse hyperbolic function. So let's start with that. So on the left hand side, a function is given which is inverse trigonometric function, and on the right hand side you can observe that there is a complex number. So pi by 2 is a real part of a complex number and log of cot theta upon 2 is the imaginary part of a complex number. So I can summarize this problem like, we have to prove that sine inverse of cosec theta is equal to a complex number. So we have to prove that it's a complex number whose real part is pi by 2 and the imaginary part is log of cot theta upon 2. So to start with the solution, I will first assume that the sine inverse of cosec theta is equal to a plus ib. So I am just assuming any complex number. So now we will take this sine inverse term on the right hand side. So here we'll get cosec theta is equal to sine of a plus ib. Now guys, since we have to prove that the value of this sine inverse of cosec theta is a complex number, we have to bring complex number. Now how to bring that complex number? So here you can observe that we have sine of a plus ib. So if I do the expansion of this term, then I'll get a complex number. So here I'll use the formula of trigonometry. So we'll get it sine a, then cos of ib plus cos a into sine of ib. Now what is the value of cos of ib? So we have seen few identities in hyperbolic function, so I'll apply it. So cos of ib is hyperbolic cos b. So here we'll get sine a into hyperbolic cos b. Similarly, the value of sine ib is I sine of hyperbolic b or hyperbolic sine b. So here you can see that we have done the expansion. Now guys, on the left hand side we have cosec theta. So it's a real part. So can we say that the imaginary part is 0? Yes, it's absolutely correct. So here I'll write cosec theta plus 0i. Now guys, you can see that on both sides we have a complex number. So we can compare the real part with the real part and the imaginary part with the imaginary part. So by comparing on both sides, we'll get the real part, that is sine a into hyperbolic cos b as cosec theta and cos a into hyperbolic sine b as 0. So now guys, let's solve these two equations and let's find out the value of a and b. So if you observe the second equation, then cos a into hyperbolic sine b is 0. So when can we get 0? So there are possibilities like cos A can be 0 because 0 into hyperbolic sin B is equal to 0, or hyperbolic sin B can be 0, or these both terms can be 0. Now let's check what can be the right possibility. So let's say first of all I am saying hyperbolic sin B is 0. So I'll write it over here. So guys, if we assume that hyperbolic sin B is 0, then B will be hyperbolic sin inverse of 0, which is 0. So it means we are getting value of B as 0. Now guys, let's come here. So if we get B 0, it means value of sin inverse cosec theta will be equal to A plus 0i, or only A. So it means we are saying imaginary part is 0. But that's not possible, because in the question it is said that the value of imaginary part is log of cot theta by 2. It means we have to prove that B is log of cot theta by 2. So it means this assumption is wrong. So it means cos of A has to be 0, because if it is 0, then only you will get the multiplication as 0. So therefore here I will say value of cos of A is 0, and therefore A is equal to cos inverse of 0, which is pi upon 2. And we got the value of A as pi upon 2. It means here A is pi upon 2, means real part is pi upon 2. And guys, that's what is expected. So in question also it is asked that to prove that real part is pi by 2, and here we got real part as pi by 2. Now we'll use this value and we'll substitute it in this given equation. So now since A is pi upon 2, so sine of A will be sine of pi upon 2, and this sine of pi upon 2 is 1, because sine of 90 is 1. So what is remaining? So here we'll get hyperbolic cos B is equal to cosec theta. Now guys, we have to solve this equation to get the value of B. So to get the value of B, I need to shift this hyperbolic cos on the other side, which will become hyperbolic cos inverse. So we'll get B as hyperbolic cos inverse of cosec theta. Now guys, to find the value of B, here I'll be applying the formula of hyperbolic cos inverse of x. So we all know that the value of hyperbolic cos inverse of x is log of x plus under root x square minus 1. Now in this formula, I'm gonna substitute x as cosec theta. So we'll get now guys, what is the value of cosec square theta minus 1? So by the rules of trigonometry, it's cot square theta, and the root of cot square theta is cot theta. So here we'll get cosec theta plus cot theta. So therefore B is equal to log of cosec theta plus cot theta. Now guys, let's simplify this value. So cosec theta is 1 upon sin theta, cot is cos upon sin theta. So we'll get now sin theta is a common denominator. So we'll write now guys, let's simplify it further. So what is the formula for 1 plus cos theta? So it's 2 cos square theta upon 2. Similarly for sin theta, I'll substitute 2 sin theta upon 2 into cos theta upon 2. So we'll get now guys, here we can cancel this 2 with 2 and 1 cos theta upon 2 with cos theta upon 2. And cos theta upon 2 upon sin of theta upon 2 will give us cot theta upon 2. So here we can say that the value is log of cot of theta by 2. That is the value of B. So guys, if we see the question, then here prove that the imaginary part is log of cot theta upon 2, and imaginary part we assumed and imaginary part we assumed as b. So we got the value of b as log cot theta upon 2. So here we got the value. So guys, here we have proved the given result, and I'm sure you understood the method. And guys, if you want that your friend should understand the same method, then you have to share this video with your friends, because friend in need is friend indeed. And don't forget to subscribe to Ekeeda channel, because then only you will be able to get latest updates and more videos from Ekeeda. Thank you very much.